Thanks to the musings of an obscure clerk working in the Swiss patent office, our next great discovery revealed that the universe is a strange, mysterious place. That clerk was Albert Einstein. In the early 1900s, he was puzzled, along with the rest of the scientific community, by the orbit of the planet Mercury. Despite the ability of Newton's laws of gravity to precisely predict the motion of the planets, the laws failed when it came to correctly predicting Mercury's orbit. The puzzle had to do with Mercury's perihelion, that point in its orbit where it's closest to the Sun. Every century, Mercury's perihelion advanced slightly, a change that Newton's equations could not account for. In a bold and startling move, young Einstein proposed his own theory to explain the puzzle of Mercury's orbit, and in the process, developed a theory that refined Newton's laws of gravity. Michio Kaku is a theoretical physicist at the City University of New York.
Newton says that gravity travels instantaneously throughout space, and that's where Einstein thought there was a weakness in Newton's theory. He wanted a theory that could explain gravity. He wanted a theory that could explain acceleration and zigzag and circular motion. There has to be waves, gravity waves. It takes time for gravity to work its magic.
To propagate.
To propagate. So if the sun were to disappear, it would take 8 minutes for us to know about that fact. Even gravity travels at the speed of light. Einstein needed a new picture to explain that. And that picture was curved space. That space itself has curved, and that's why objects move.
Einstein believed that his concept of curved space was responsible for shifting Mercury's orbit. Einstein called his idea the theory of general relativity.
Imagine a trampoline net and place a bowling ball in the middle of a trampoline net. The bowling ball sinks into the trampoline net, and now shoot a marble around the trampoline net. The marble will orbit around the bowling ball. Now, from a distance looking down, Newton would say that there is a force, an instantaneous, invisible force pulling the marble down to the bowling ball. But Einstein would say, there's no force, there's no pull, it's just a trampoline net. And why is the marble orbiting around the bowling ball? Because the trampoline net is pushing the marble. Therefore, why am I sitting on this chair? Not because gravity pulls you to the ground, it's because space pushes me down toward the planet Earth.
The idea that space itself was warped by mass was too strange for many to accept. An approaching solar eclipse gave scientists the perfect opportunity to put Einstein's new theory to the test. Photographs were taken of the background stars before the eclipse and then afterwards. These pictures were then compared with photos taken during the eclipse. The photos showed that the positions of the stars in the eclipse photo shifted slightly inward, bending as the light from the stars passed the sun's gravitational field. Einstein's theory of general relativity was right. His great discovery rocked the world.
General relativity strikes a deep emotional chord in anyone who's ever looked at these equations. These equations are 1 inch long, and yet they answer these eternal questions that have dogged us ever since we first looked in the night sky and asked ourselves the question, what's it all mean?
Now, before we push that big button in the control booth, before we vault up to that video viewer in the sky and on the cable, before we stop with this long introduction to the #1 great discovery in science so far, I just want to point out that this one is controversial. This one gets people's hackles a-hacking. No matter how you feel about it, bear in mind that our next #1 discoverer came across some things in nature that surprised him, and he tried to explain what he saw. It's not the story of a guy just trying to cause trouble. It's the story of the guy who made what you and I consider the #1 discovery in science so far.